Today we will be working on the following problem. Let Y be a dense subset of a topological space X, and let F be a continuous function on X. And for all n greater than or equal to 1, F sub n is a continuous function on X. Now we suppose that for all Y in this dense set Y, F sub n of Y converges to F of Y as n goes to infinity. So the first question is it always true that for all x in X, f sub n of x converges to f of x as n goes to infinity? And B says we want to prove that if we assume f sub n is a pointwise equicontinuous, then A is true. F sub n of x converges to f of x for all x as n goes to infinity. Pause the video if you want to work on this problem by yourself. Okay, let's see. For A, basically for A, the answer is no. So we can construct a f of x such that f, find the topological space X and then subset of Y such that the conclusion of A does not hold. So let's we let X to be just the closed unit interval, and the Y is just open 0 and then close on Y, right? And then under the absolute value is the matrix, right? So clearly this Y is dense in X. And now we define this f sub n of x to be like this. For I just draw a picture like this, right? So this is 0, 1, x, and 1. So for any 1 over n over here, and this is 1. So we just use the segment, the linear, from this to 1, and then from n equal to 1, from 1 over n to 1 like this. So f sub n defined to be a function like this, right? So then it is clear for any y in this Y, f sub n of Y goes to 0. And then we define f of x to be always 0 on x, right? So, but if you do the at 0 point, f sub n of 0, which is always 1 by definition, right? So this is f of x, the picture of f sub n of x, right? And this clearly does not goes to 0, which is f of 0, right? So this is a counter example. Now for part B, so we want to prove this, right? So by assuming f sub n is a pointwise equicontinuous, so we can use this standard argument for every epsilon greater than 0, for any x in this X, right? We know there is an open set, let's say H sub X, which is open depending on X and on epsilon, right? This one, there is an open set of this. So X in this open set, such that, for any Y in this open set centered at X, containing X, right? This implies f sub n of Y minus f sub n of X, the absolute value is less than epsilon for all n. This is basically the condition for f sub n to be pointwise equicontinuous, right? So now for this x, right, since by assumption f is continuous at x, so we can find a open G depending on x open, and then G sub x contains this x such that, because f is continuous x, such that for any y in this G of x, we have f of y minus f of x taking absolute value is less than epsilon, right? This is the definition for f continuous at x. Now we use the assumption like since y is dense in x. So since y is dense in x, what does it mean? If y intersects any gx intersect h sub x, this is open, right? Oh, they both contain x. It's a non-empty open set, and the y is dense, so y intersect any non-empty open set is not empty. So we can choose some y in this because it's non-empty, right? Now for this y, because by the assumption for this y, f sub n of y goes to f of y as n goes to infinity. For this y, there exists some n such that when small n bigger than this big N, f sub n of y minus f of y, this less than epsilon, right? Because f sub n of y converges to f of y as n goes to infinity, so we have such big N. Now we just use the standard argument, the triangle inequality, so when small n is greater than big N, we have f sub n of x minus f of x. That's all equivalent. We just use the triangle inequality. We can write down like this: f sub n of x plus f sub n of y minus f of y, absolute value, and then plus f of y minus f of x, taking the absolute value, right? So now based on what we have, because this y is in both of g sub x and h of h sub x, right? So the first term, because of this less than epsilon. The second term is because of f sub n goes to f sub y, so for this. And the third term is because f is continuous and x, right? So this is less than 3 times epsilon. So which gives the f sub n of x goes to f of x for all x. Yeah, that's it.